last section for Algebra 2. We are going to move on to another graphing topic. Okay, make sure. Okay, oops. Here we go. Okay, see, this is what we are going to do. We are going to graph the quadratic equation and two variables. What kind of equations are the quadratic equation in two variables? First, we know this quadratic means what? Means we see a variable which has a power of 2. Okay, still not very clear. Here we go. And recall what we did in Algebra 1. I hope you remember this. So we have learned if we have an equation like this, y equals some number, we call it m times x plus another number. So m and b are two constants. Y and x are two variables. This is called what? A linear equation. So this is the linear equation in two variables. Y and x are the two variables. The graph of a linear equation, we know is going to be a straight line. So any straight line will have a slope. So y is the slope, and b represents the y-intercept. Where does the line cross the y-axis? So this is what we did in Algebra 1. In Algebra 2 now, we are going to move on to another equation in two variables. It also starts with one variable y. So y equals a function of x. And this variable x has a power of 2. So that's why we see the quadratic equation. So it will have a form of some number, a represents any number, times x squared, then plus b times x plus c. A, B, C represents three constants. They can be any number. So a, we just see, because we have to have this square term, so a can never be 0. A is a non-zero number. A can be positive, a can be negative, can be any number other than 0. And one equation has a format of this. This is called a quadratic equation in two variables. Y and x are the two variables. What we are going to do today, we are going to learn a lot of things about this type of quadratic equation. How do we graph it? What kind of graph will we get? And if there are any special points on the graph, how do we know those special points? So there is a lot of things that we will be studying about the quadratic equation in two variables. So first, I want you to memorize. This is called the standard form of a quadratic equation in two variables. Why? Because it's standard, because some equation might come in different ways, but eventually we want to get y alone on the left side. Then on the right side, that will be just one expression of x only. We won't see y on the right side. The right side will only be a function of x. That is called standard form. And for the standard form, we have to know what the three constants are. Those represent the coefficient of the x terms and the constant. If we know what A is, what B is, what C is, then we'll be able to answer a lot of questions about the graph of the quadratic equation. Okay, so let's start with this. So how can I rewrite one arbitrary equation into the standard form? So we are not always be given the standard form. For example, we got y equals 3x plus 5x squared. So sometimes we are given, so this is example 1. We are asked, rewrite the equation into the standard form. Then recognize what A, B, C are respectively. So we write down A equals B equals C equals. So for this equation here, let's say the standard form. First, we'll say, well, Y equals, Y is on the left side by itself, that's good. Then we check the right side. For the right side, we'll notice for the standard form, we always start with the quadratic term first, then followed by the x term. Finally, we get a constant term. Okay, see, the square term, 5x squared, comes first. We use the commutative law. We can switch the orders of the terms. 5x squared and then plus 3x. Okay, there is no more. Well, this, we can see this is standard form. Y stays on the left side by itself, and on the right side, we have a descending order of the x terms. Then we write down, what is A? A is the coefficient of the square term. So before x squared, A equals 5. There is no doubt. What is B? B is the coefficient of x. So that will be 3. So remember, if we have a minus sign in the equation, we always give it to the next term. So if we have minus 3 here, B will be negative 3. But here, because this is plus, B equals positive 3. Then what we need C. There is no constant number in the equation. That means C equals 0. But still, for the standard form, let's write down the 3 constants, so A, B, and C. That's what we need. So we are done with the preparation for the following things if we know how to rewrite the equation in the standard form. Okay. Now, the second thing I want to tell you is for any quadratic equation in 2 variables like this, we could graph them the same way as we did for the linear equation. For linear equation, we know if we know any 2 points, connect the 2 points, we'll get a straight line. And the shape of the quadratic equation will not be a straight line anymore. It's going to be a curve. And this curve is very special. Okay, so let's see if for any given quadratic equation in 2 variables, those the graphs we might see. So first we'll have a XY Cartesian coordinate system. For every single quadratic equation, if we plot them how, we find a few points which satisfy the equation. For this, it has numerous solutions. Whenever we have an x, we will have a corresponding y. We give an x to another number, we get another corresponding y here. So this equation has numerous solutions. When we get all those solutions, we'll get numerous points. And when we connect all those points here, we'll find it. So they will have the shape like this. Okay. So every single, the curve right here, they have one corresponding quadratic equation. See, for this kind of the shape of the curve, we'll see they're pretty special, right? And they either opens up or opens down. And all of them, they're symmetric. So which means if we fold them through the point and the left side and the right side, they're all match. So we can fold them. This is symmetric. So they are all symmetric about a line here. And every single curve, they will have either the highest point or lowest point. So when it opens upward here, we'll have a lowest point. When they open downward, so the curve can be extended to the infinity. So they can go infinite low or infinite high. And if they opens downward, then they will have a highest point. And for all those special things, right, so some of the curve, they will cross the horizontal axis. And some of the curve like this, it never crosses the x-axis. So for all those special things right here, we are going to work on one by one. The first thing, so what do we know? First, we know the graph that we see now, they have a special name, and they're called parabola. For all those curves, the graph for any quadratic equation, they are all called parabola. And when we have parabola here, first thing we want to know is opening. Does the parabola open upward or downward? See, the mouse opens upward or downward. Is there any way that we can know directly without plotting the graph when we're given the equation, without plotting them? So we do not have to look for a lot of points on them, on it, and then connect them. Without doing this, can we know the opening directly? The answer is yes. So this is what we are going to memorize. What do? We are going to check the coefficient A. If A is greater than 0, so when A, the coefficient of the quadratic term, is a positive number, it always opens upward. When A is a negative number, it always opens downward. So it can be anywhere depending on the equation, but we just look at the mouse. Is the mouse opening upward or downward? It is only determined by what? By the coefficient of the square term, the constant A. If A is positive, it opens up. If A is negative, it opens down. That will be a very typical question we will see in the next quiz or in the coming final exam. Okay, very simple. Just memorize this. No trick at all. Remember, A can never be 0. If A is 0, it's not going to be a quadratic equation anymore. It's not going to be a parabola. Second thing here, let's see, we have noticed, all right, every single parabola is symmetric. So which means there will be a line in the middle for every parabola. And this line here, we call it the symmetric line or the line of symmetry. First, we know all those lines, they are vertical. So for all vertical lines, it means their x will always be a constant value. Y can be very big, very small. So for all vertical lines, they all have a format of the equation as x equals a constant, a number. So for every single parabola, what is its own line of symmetry? Here comes the formula. So x is determined still by the equation itself. Every single equation has its own line of symmetry. And this line of symmetry has equation of x equals negative b over 2a. Okay, I'm going to highlight this. And this is the formula we are going to memorize. For any parabola, its line of symmetry is always determined by the constant in the equation, a and b. X equals negative b over 2a. Okay, how do we get this? See, that's why we said after we have the quadratic equation, we have to know what a is, what b is, what c is. See, for this equation here, what is its line of symmetry? Just plug a and b into the formula. X equals negative b over 2a. So then b is 3. So negative 3 over 2 times a, 2 times 5. That will be negative 3/10. if we are going to plot this quadratic equation, we'll get a parabola here. And this parabola has a line of symmetry as x equals -3/10. Right, so this is the second thing we are going to memorize about the graph, the parabola. Every parabola has its own line of symmetry, and x equals negative. Don't forget, we have a negative sign, negative b over 2a. Okay, the third thing that we want to know about parabola is what? The special point, the lowest or highest point. When the parabola opens upward, so which means it can extend upward to the infinity. So it has the lowest point. When it opens downward here, it has the highest point. And I also want you to notice, okay, so this, I didn't graph it very well here. If I graph the parabola perfectly, we'll notice the turning point or the lowest or highest point, because this is where to make the turn. Okay, the turning point or the lowest point, highest point, they are just staying on the line of symmetry. So where the line of symmetry crosses the parabola, that point will be the turning point, will be the lowest point or highest point. So this point on the parabola, we give them a special name. They're called vertex. Okay, so another terminology right now you got to memorize. Vertex means what? Vertex of a parabola represent the turning point, which will be either the lowest point or the highest point. How do we know where the vertex is? So vertex is a point. And for any point, we need to have two coordinates. So some number, this is x, this is y. How can we find out the coordinate, the vertex, the point of vertex, or the two coordinates of the vertex? As we said, so first, the vertex is on the line of symmetry. Second thing, the vertex is also on the parabola here. Okay, so to find out the special vertex here, and we will use the line of symmetry because the vertex is right on the line of symmetry. So then we know what? We know this x for the vertex here is horizontal coordinate. X is always equal to -b over 2a. Why? Because it is on the line of symmetry. The line of symmetry has x value of -b over 2a. So this horizontal coordinate can be determined by the line of symmetry here. The other thing here, because x and y, they have to satisfy the parabola, the quadratic equation, because this vertex is on the parabola. So y and x, they are related by the quadratic equations. After I know what x is, how do I get y? So y can be calculated by this quadratic equation. Y equals ax squared plus bx plus c. So plug whatever number we have here into the quadratic equation. We know a already, we know x now, then we can calculate what y is. Okay, so now let's look at one specific example here. So example 2, find the vertex without plotting the quadratic equation. So y equals -x squared plus 3x. No, let's use a big number, 6x plus 3. Okay, so what do we have here? We have a quadratic equation. Is it in standard form? The answer is yes, because we know y stays on the left side by itself. On the right side, x terms have the descending order. Then we'll write down the corresponding coefficient. So a equals what? What is before x squared? A negative sign. That means a equals -1. What is b? B is number before x. B equals 6. What is c? C equals 3. So we do not use c for now, but we still write them down. Everyone down. So a, b, c, we know all of them. And then to find the vertex, I'm going to find the x coordinate first. X equals -b over 2a. Okay, this is the recipe. You really don't have to derive this by yourself, and you just need to learn how to use it, how to apply this recipe. Write this down. Then plug a and b into the formulas. And equals negative. What is b? B equals 6. And then times 2 over 2a. What is a? A equals -1. So that is 6 over 2 times -1. Don't forget we have another negative sign. Okay, see, simplify this. 2 times -1, that's -2. 6 divided by -2, -3. -3, that's +3. Or you see, there are 2 negative signs in this expression. Negative turns into positive. So x equals 3. And this is the line of symmetry. And it also represents the horizontal coordinate of the vertex. We are not done yet. Now plug x into the original equation here. Solve for y. Y equals what? Y equals -x squared plus 6x plus 3. That's y. Because we know x already, then that will be -3 squared plus 6 times 3 plus 3. Simplify this, follow the PEMDAS rule. We got -9 plus 18 plus 3, that is +12. So therefore, we can answer the question here. The vertex is what? Is a point. The point has coordinate of 3, 12. Done. This is another typical problem you will see on the final. I believe on the final, we will be, or on the coming assignment, the homework, you will be working on some typical problem like this. How can we find the vertex? Recall. We get x first. X is always -b over 2a. And then plug x into that quadratic equation. Solve for y. Put them together. X comma y. That is the vertex. Okay, and this is the key. Only after we know what x is, we will be able to find y. And what x is staying on the line of symmetry. X is always equal to -b over 2a. This is the third thing we should know about the parabola. The next one, okay, we notice so the parabola, if I extend it, okay, see this parabola crosses the horizontal axis, and this parabola also crosses the x-axis. So every parabola, if, okay, we'll see when it crosses the x-axis, we'll see 2 points. So those 2 points, that's where this parabola crosses the x-axis. Those 2 points are the points where this parabola crosses the x-axis. And this one, okay. So for this special point on the horizontal axis, they are called x-intercept. This concept is not new to us. And when we are working on the linear equation for the straight line, we have seen this concept before. But now let's see, is there any special thing about the parabola? So we'll see for all those 3 parabola, we know every one of them, they'll have 2 x-intercept. But when we look at this parabola right here, so no matter how hard we extend this parabola here, go to infinity, there will never be an x-intercept. Why? Because this parabola is above the x-axis. It will never cross the x-axis. So that means this parabola or this quadratic equation does not have an x-intercept. But those three, they have two x-intercept. Let's see, there might be another special case. I have one parabola right here, and it touches the x-axis at one point. So that means this parabola have just one x-intercept. And I want you to remember, so not every parabola has x-intercept. Sometimes it has two x-intercept. Sometimes it has just one. Sometimes it has no x-intercept. But how? So if I have one quadratic equation without plotting it, am I able to determine there is no x-intercept, or there is just one x-intercept, or there are two x-intercept, and they are blah and blah? How do I answer those questions? Is there any formula or recipe that we can work on the x-intercept problem? The answer is yes. Okay, see, the x-intercept means what? Means the point should be on the x-axis. So when we are looking for the x-intercept here, every point on the x-axis, they all have the y-intercept be, not y-coordinate be 0. So what do we do now? To look for x-intercept, it's the same thing as we did before for the linear equation. We just let y be 0 and then solve for x. See, when we are given the equation originally, we had y equals ax squared plus bx plus c. If we let y be 0, what do we have now? We have a typical quadratic equation. So we could switch the two sides. 0 equals ax squared plus bx plus c, and which is equivalent to ax squared plus bx plus c equals 0. Let y be 0, solve for x. Do we know how to solve the x? This is what we have been doing in chapter 9. How do we solve the quadratic equation in one variable? X is the only variable. If we can factor it, the factor method is the best way, is the fastest way. If this is not factorable, then we'll use the quadratic formula. X equals negative b plus or minus square root of b squared minus 4ac, and then divided by 2a. That's called the quadratic formula. It can be used to solve any quadratic equation. Not always. So we know for when we use the quadratic formula, right? And the number inside the square root, I showed you last time, we call it delta. Delta equals b squared minus 4ac. If b squared minus 4ac is greater than 0, it means greater is a positive number. It means that quadratic equation has two different solutions. If it has two different solutions, then it means it has two x-intercept. It crosses, it will be the parabola like those three. If this delta is exactly equal to 0, that will be this case. This quadratic equation will have two same solutions, or we can see it has just one solution, one root, which means it will have just one x-intercept. If this delta b squared minus 4ac is less than 0, it's a negative number, then it means what? It means there is no x-intercept. it has no real solutions. It has no x-intercept. So this is how do we get x-intercept. First, let y be 0, then solve for x. If there is no solution at all, that means no x-intercept. If there is just one solution, it means there is just one x-intercept. If there are two solutions, that means that there will be two x-intercept. That's it. And nothing new right here. After we get delta, then we just got x equals 2a negative b plus more minus this delta. Delta equals b squared minus 4ac. That's the solution. And nothing new right here. You just need to remember to look for the x-intercept. We let y be 0, then solve for x. How do we solve x? That's what we did in the beginning of chapter 9. Okay, so I think that's all I want to share with you. So vertex, line of symmetry, the opening, the x-intercept. That's it. And just one more thing, if you happen to be asked for the y-intercept, you just let x be 0, then solve for y. So just let x be 0, solve for y. Y will always be equal to c. So 0, comma c will always be the y-intercept. The y-intercept is where this line crosses the y-axis. So every line will be able to cross the y-axis. Why? Because they will be able to be extended to the infinite point. So eventually somewhere this line will cross the y-axis. So y-intercept always exists, this y-intercept, and it always equal to 0, x equals 0, y equals c, because x equals 0, this term is 0, this term is also 0, y equals c. So 0 comma c is the y-intercept of the parabola. But this is not a very special point, and we might not see a problem to look for the y-intercept. I just wanted, if you're curious about the y-intercept, this is what we are going to do. All right, I think that's all I want to share with you for this semester. We are done. Let me stop recording.